This is a pretty interesting question. We have a tube in which the middle 5 centimeters has mercury. Now when the tube is held at 60 degrees with the vertical, the length of air column above the edge is given to be 46 centimeters and that below is given to be 44.5 centimeters. The temperature of the system is constant and is given to be 30 degrees Celsius. We need to find out the initial pressure in this column in centimeters of Hg. So for solving this question, let us first draw the diagram. When the tube is held at angle 60 degrees with the vertical, there is a mercury column here. Let this length be L1 and this length be L2. This is already 5 centimeters as we already know it. Now let the pressure here be P1 and the pressure here be P2, and let us apply Newton's law on this column of mercury in this direction. Therefore, while applying equation in this direction, let us draw all the forces first. Whenever you are applying Newton's law, be careful that you draw all the forces. So there is an mg acting on this column of mercury in the vertical direction. A force equal to, this was P2, this was P1, P1 into A, which acts in this direction, and a force P2 into A acting in this direction. Therefore, we can write P2 into A is equal to P1 into A plus mg cos 60 degree, that is equal to mg by 2. Therefore, we know P2 is equal to P1 plus mg upon 2A. This is one equation that we have. Now we see that, let us compare. This is a column of gas. This column of gas comes over here. So for this column of gas, let us apply PV is equal to nRT. For this column of gas, the number of moles does not change because it is restricted in an area and it cannot escape. The temperature is fixed, therefore the product of PV is equal to constant. You can always take as to what is constant by applying a single equation, PV is equal to nRT. You need not remember any other special law except PV is equal to nRT. Therefore P1 V1 can be equated to P2 V2. That is, here P1 V1 is the initial, let me write it as P initial V initial is equal to P final V final. Therefore applying this for this column of gas, we get P into L is equal to P1 into L1, the area of cross section gets cancelled. Similarly, we can write P into L is equal to P2 into L2. Therefore, P2 over here can be written as P into L upon L2 is equal to P into L upon L1. This is L1, this is P1, this is P2, this is L2 plus mg upon 2A. Now, we can write P into L into 1 upon L2 minus 1 upon L1 is equal to mg upon 2A. Therefore, P into L into L1 minus L2 upon L1 L2 is equal to mg upon 2A. Therefore, P can be written, we need to find out P. This P can be written as mg L1 L2 upon 2AL into L1 minus L2. Now we need to find out this P in centimeters of Hg. Therefore, we write this P as rho of mercury into G into H centimeters of mercury is equal to mg L1 L2 upon 2AL into L1 minus L2. Now, mass of, this is the mass of mercury over here. Therefore, mass of mercury upon the density of mercury can be written to be volume of mercury, that is equal to A into 5 centimeters. Therefore, let us write into A into 5 centimeters over here. This G gets cancelled with the G over here. So, our answer for H is equal to L1 is given to be 44.5. We feed in the values of L1 and L2 over here to get 44.5 into 46 into A gets cancelled into 5 upon 2 into L1 minus L2, that is 1.5, and L is equal to L1 plus L2 by 2. Therefore, we write this as 45.25. So, the answer for H comes out to be equal to 75.39. Therefore, our final answer for the initial pressure in this column of the tube comes out to be equal to 75.39 centimeters of mercury. That is a pressure equivalent to the pressure of a column of mercury of height 75.39 centimeters.